Welcome to the Epik Mellon podcast, conversations with the real humans behind broadband networks, cybersecurity, and the future of communications. Brought to you by QA Cafe. In this episode, we talk to Tim Winters, CTO of QA Cafe, about standards, the evolution of IPv6, and the people behind it. All right. Hi, everybody. I am Jason Walls, your host from QA Cafe, and welcome to the Epik Mellon podcast, where we talk about the crazy world of networking and all the people behind it with some really cool stories, a little bit about technology, a little bit about where things are going in the future. But we're here to have fun. This has been the brainchild that I've had for a while, just knowing all the people that I know in the industry and the cool stories we have and sort of how it is that we all got to be here in the first place. So I thought it would be interesting for other people to hear it. So just a little bit about the show. Obviously, we are, entirely funded by my employers, right? QA Cafe. So the views expressed by myself or any of the guests here obviously don't reflect those of QA Cafe or its ownership. I want to make that super clear. And QA Cafe makes three very, very cool products for the networking industry. The first is CD Router. CD Router is the industry standard test solution for broadband gateways, Wi-Fi routers, and other CPE, customer premises equipment. It contains thousands of test cases that are designed by network experts, some of us included, I would like to think. And that covers feature validation, stability, certification, performance testing, all in one tool. It is designed with full automation in mind, with a robust API that lets developers work seamlessly with their CI/CD environment. Since its use is so widespread among operators, manufacturers, OEMs, and chipset vendors, replicating tests and communicating requirements between customers makes it sort of the de facto standard for testing. And moreover, our world-class support team, who's sitting right out there, acts as an extension of your own, helping you understand the technologies and building better products overall. Our second major product is called CloudShark. CloudShark is the way to make network packet captures an easy and useful part of your networking, IT, and cybersecurity workflows. CloudShark takes complex tools like Wireshark, Zeek, and Suricata and presents them in a truly accessible way to you, your team, and your customers. CloudShark helps you work on tough issues together without passing around large capture files, losing data, or risking security leaks of valuable network data. In addition, CloudShark is designed to help entry-level analysts work with your senior experts, curate best practices, and standardize operating procedures around packet captures. And last but not least is our Passport product. It is a fully automated solution for testing the connectivity and interoperability of IoT and smart home devices. As CD Router is to routers and gateways, Passport is to end devices. By emulating a real home network, Passport enables repeatable network testing for ensuring IoT and smart home devices behave as intended for your customers. Designed with ease of use and automation in mind, testing with Passport is as simple as connecting your device, selecting tests, and getting clear pass-fail results with full log data and packet captures to find and resolve bugs before they end up as a bad review of your product. That's my little advertising sponsorship speech.
Wow. I was mesmerized.
Yeah, right? It's almost like I didn't just write that this morning. No, this is all standard messaging, everybody. I swear. So the title of this podcast is called Epik Mellon, and it sounds pretty strange, but I want to sort of explain why that is the case, right? So when I had the idea for this a while back, I'm a language geek, right? I'm a language nerd. I'm a nerd about a lot of things.
I'm aware. Yep, I'm aware.
Tim is also nerdy about a lot of things, right?
Not the English language though. We'll get into my nerd habits later, but definitely not the English language.
And I wanted to, so every now and then I'll be like, I'm trying to come up with a cool name for something. I'll see what it is in another language and see if I can sort of make a portmanteau about it, right? And so I was like, all right, what is the Greek for the future of communications? And it turns out that it is Mellon Epikoion. Epikoionion. Anyway, if there's any of my Grecian friends out there, please feel free to correct me, right?
Yeah, I can see we're going to get some hits on
right. You're like, actually, Jason, the pronunciation was Yeah. And when I saw that, I was like, man, that is perfect. Like, how could I not name that Epik Mellon?
Okay.
So on this show, we will talk about the future of communications. Probably we might talk about very well hydrated fruit products. I don't know, Epik ones.
Not in my nerd category, but okay.
Well, I used to work in the produce department of a grocery store, so it might come up.
That's right. That's right. Wow, you got such a diverse background, Jason. So diverse,
right? Don't we all? Speaking of which, so here's what you will hear on this show and why. I wanted to talk about how networking really is a crazy world. And I say that's a good segue because I was just talking to Tom, actually. And I've, in my experience, almost none of us, and maybe this is the case with like a lot of different, different careers out there, but almost none of us got into networking on purpose.
Yeah, no, you're right. I mean, it's definitely true in my case, for sure.
Yeah. It's like a lot of us were in EE or CS. That's probably true, and we started to get there a little bit. And there certainly are the people, and you know the people I'm talking about who were hardcore. I understand multidimensional calculus very well, and it is not hard for me. And I'm going to get into Wi-Fi radio design. I'm sure that those people did that on purpose, right? But from the vast majority of us, we did not get into networking on purpose. And it's a crazy world. It is a crazy world. And I express, whenever I try to explain to other people, right? So my teenager says, oh, my dad goes to bars to help make the internet go, right? Or to make rules for the internet. Right? We know a lot of people. It's a very... it's an industry where everybody knows each other pretty well, right? And if you see somebody leave, you'll usually see them come back somewhere else, right? Yeah,
it's true.
And
a lot of people stick with the networking. Once you get the networking bug, you kind of have it. Right?
Mm-hmm.
That's it's definitely one of the themes. Like you said, people come and go, and they're working on different problems, right? I think is what we discover. And as time has gone on, right, they're working on different problems because, like you said, there's multiple ways to communicate, right? And so we're just coming up with new ways. It might be a different area, but you're still trying to figure out how to make stuff work together.
Right. Yeah.
In essence.
Mm-hmm. Yeah. And so it's like whenever it just happened today, I heard of somebody moving on to another job position. I was like, we'll see you again. It's not like
It's true. It's a smaller world than you think. It's true. Right?
So I wanted to expose. So one of the things I always tell people, is that especially for people like Tim and I, and I'm going to be talking to a lot of different people from a lot of different areas of the industry. But for people like Tim and I, we do a lot of work in standards, and standards worlds is even crazier.
Yeah.
Right.
Yes.
And what I want to tell people, what I usually tell people is like, look, I am not joking when I say that the internet works by accident. Like, or rather, there are a lot of decisions that were made.
Yes.
Right. And you don't necessarily want to know how the sausage was made. But I feel like on this show, we can reveal a little bit about how the sausage was made. And I don't just mean the technology. I mean, like, the real people behind this, like the mavericks and the weird cowboys that we know that sort of make this go,
Yeah, definitely. I think, like you said, by accident, it's not quite right, but I can 100% say it's not by design.
Yeah.
The way the internet works right now is definitely not a design. It's like the city of Boston, with the roads going every which way and every which direction, right? We didn't grid it out. There's definitely no grid situation. It's very much a bit chaotic, but we're here and it works great.
Right. And some people try to do that,
unplanned.
which is what Tim and I will talk about a little bit today. Some people try to do that. And then when that meets the rest of everything else, you realize there's a lot more standardization to do.
Yeah, it's true.
So that's
totally true.
That's what I wanted to do on this show. And you're going to hear a lot of stories like that, but also some sort of like real human stories, like people who I know who were, field techs in broadband, right? And some of the interesting stories they have of people they've run into and the reason why certain problems were happening that were totally crazy, right? The only thing I would want to talk about before getting started is sort of how I got into all this, right? Because I came in and, I was a CS, I'll say I was a CS dabbler, right? It was like,
Is that what you're going to go with here?
I've always loved it. I got to the point where I was like, I don't know if I want to do this every day of my life. And then, I ended up started working for an organization at the University of New Hampshire called the Interoperability Laboratory, which is very, very open about taking people and throwing them into the networking world wherever they came from.
Yes.
Right. And it kind of works. And what's cool about that is everybody sort of brings their own background into what it is that we know and we do.
Well, that's what's interesting about networking. You don't need a programming background to be able to figure out how to network things. And I think that's where things get a little bit fuzzier. Over the last 20 years, we've seen universities change programs and move some of this around because you don't have to be able to program. You don't have to know 9 programming languages to be able to create a network.
And you do need to know a little bit. So I'm not going to hear people, razzing me later from being like, oh, well, you do need it. You do need to understand engineering. But
I don't disagree with that. But I guess that's what I'm saying is that I don't think you need to be a programmer, but I also don't think you need to be, you can learn a lot of this through trial and error is the wrong word. You can learn a lot of this as part of just gaining experience.
Yes,
which is where I think the IOL had it right.
No, right, and that's where I came from. Right, it's like I was coming in with CS and I wasn't really that into it after a certain period of time.
Yeah,
and then I started getting into the business aspect of things, and then the standardization side of things, and seeing how the real world operates, and how that all has to try to fit together. And the political decisions that are made, the business decisions that are made, and I found all that really cool. That's why I now helped you. That's why I do marketing for QA Cafe now, right? But in addition to all the standards work that we do, so that's where I am. That's how I got here. And one of the reasons I wanted to talk to Tim first, as kind of our first episode, is because he has his own experiences in that department and how he got started in all of this.
Yeah. So it's funny how I got started. Just a little bit of background on me is I originally out of high school. I couldn't decide if I wanted to be a business. I was looking at this because my son is looking at schools now, and he knows exactly he wants to be a programmer. That's what he wants to do, which is super exciting. I did not. And he didn't even fathom this when I was talking to him. He knows nerd dad who's been doing this. And I was like, no, like half the schools I applied as business. And the other half I was undeclared engineering because I knew I wanted to be in the engineering school, but I had no idea what I wanted to do. And, every guidance counselor at the time, so I'm going to date myself here. This is the late 90s, right? Was telling you, don't be a programmer. You can't program video games all the time. Only had they hung around long enough, they would have seen how wrong they were. But at the time, that was like the messaging. You fill out that little form, they tell you what jobs you can have. And I filled it out. And I ended up, I love the University of New Hampshire. So I decided to go there, and I was undeclared. I'd taken CS classes at my high school. I had done, those were really, I would say, managing an IT system. I got to see Red Hat. Linux that was the big thing I did in high school. So I thought I'd take an introductory CS class, and it stuck. So I started doing that. And then how I got into networking was, I'm sure, similar to you. What happened to me was I applied for an internship at Intel in California. So I was in my sophomore year, and I got in, and I was like, great. Went out there, visited them at spring break. I was all set for the summer. And then that was the .com bubble. And the job went away. Now, as you know, the IOL lags. The IOL at the time lagged industry. So they had all of this yearly membership money, and they were hiring boatloads of people. So I switched jobs. I was like, I'll just get another job. It'll be like an internship, and I'll work at the IOL. And I went in, and I got interviewed by a bunch of managers for different positions. And they asked me a whole slew of questions. And the one I answered was, they answered the brain teaser about shaking hands. Like, how many people in the room, like you walk into a room, how many times do you have to shake hands? It was one of those questions. And I answered it that I would write a program. And I was like, I'm not figuring this out on the fly. I was like, I would totally write a program, and I would do a for loop, and I would iterate through everybody. And that's why the IP manager hired me. Thank God I didn't end up in a DSL or one of those awful groups that does physical layer old stuff, right? Who would want to be in one of those? So I actually ended up originally in the VLAN group doing like bridge testing, right? And I started there, which ends up being very helpful in my career. At the time, I thought VLANs were really lame, and now we've used VLANs in all kinds of unique ways. Here we are 20 some years later. But at the time I started there, then I moved to the routing group, and I did that for I want to say I did that for 4 years.
Mm-hmm.
And then, the V6 group, which is what I spent most of my time doing, heads up. We're going to talk a lot about V6 during this podcast, I assume. V6 was kind of a thing that was happening in the lab, to be completely honest, right? And so I had seen V6 packets. I had heard about this thing called V6. I had heard the horror story we were going to run out of V4 addresses like it was a scarce resource. And and we were going to run out, and there was going to be all these problems, right? And this was at a time. So I started at the IOL. The IOL was really great in teaching me the basics for a lot of things, how things worked. And then in 2005, I started working on what happened was V6 was getting to the point where people wanted to see it work outside of the world.
So how long?
So two things kind of happened
in the timeline now.
Go
like
ahead.
how long had V6 as the standard been around at this point? Because this is very important to our story.
I think this is 98. I think is when the first one came out, and after so I didn't participate in that part of like the making of it. By the time I got there, it had just been put into stacks. Like it wasn't even in the Linux stack when I started. Like it was routers would see V6 packets and just freak out. Is where my journey started with it. So it had been standardized, but it wasn't anywhere near deployment. It was really theoretical, and V6 packets basically only appeared in labs.
Right.
That's when I started.
Right.
And then two projects happened for me. One of them was Moon V6, which was a really cool collaboration with the Department of Defense, Internet 2.
And I remember there was a specific reason why they called it that, right? Moon V6?
Yeah, it was going to take the same amount of effort to go to the Jim Bound, who we'll talk about in a minute. Jim Bound definitely 100% came up with this idea of it was going to take as much effort as to get to the moon to get V6 out the door. And so he came up with we're going to call this Moon V6 because it's the same amount. This is a race. This is going to take us a lot of effort. This is not a short trip to get V6 out. And so the Moon V6 network was a collaboration amongst Internet 2, the Department of Defense, a couple service providers at the time. I'm going to say, what was MCI?
Oh, yeah.
Wow.
Wow.
Yeah. MCI. Yeah. So all of these guys, and all we were trying to do was get a V6 over a wide area network. We were literally just trying to send regular V6 traffic over a wide area network and make sure that this had a chance to actually work outside of laboratory environments, or I would call them limited domains, right? Where, great, I can send traffic through my router, but can I get it from Arizona to UNH down to North Carolina?
Right. Meanwhile, the layer 2 guys were like, oh.
Yeah. Yeah. So we did that. It was very successful. We wrote some really cool white papers. We did them for a couple of years. We focused on different areas, firewall. So that's how I first got involved. And I really got involved because we had to do it in multi-sites. And so they needed to grab extra students. And that's how I started dabbling actually in the V6. And then the other part of it was the IPv6 Ready logo. So what happened there was there was a couple of labs in the world, Tahi in Japan, UNH IOL, there was a lab in Europe. We were all starting to create V6 test cases because people were asking for it.
Right.
And Jim Bound, who was working at HP, but he was the IPv6 forum president, really about promoting V6. He had participated in many of the original standards, was like, I can't have 5 of you creating 5 different ways to test IPv6. Japan's doing one thing, you guys are doing something different. We were at the interoperability lab, so at the time we were very focused on interoperability. Right. Obviously, we were trying to hook them up, make them work. The Japan lab was very focused on the conformance, literally going through and testing all the musts and shoulds. And he had this brilliant idea to get us all together. And so we did. And that's when we made the IPv6 Ready logo. And phase 1 was the early version that the Japan folks had worked on, Tahi. And then phase 2 was basically the combination of all this. And that's about 2005.
And that was
a big deal.
Effectively a certification and interoperability. So for those who don't know, right? So we're in this a lot. So there are, when we're talking about testing, right, which QA Cafe is definitely, that's our primary products around that. We talk about validating the actual like behavior of a protocol in accordance with the standard, and then you talk about testing how it actually connects to other things in reality, right? And so this was sort of the marriage of those two things, knowing that the marriage of those two things was required in order to get this to work, right?
Yeah, I mean, that was the big discussion at the time, right? Is it was a kind of unique. Wi-Fi had started their certification programs for networking protocols were not ubiquitous yet, like they are today. At the time, Wi-Fi was really the only certification in town. They've been really the only successful one up to that point. So I'd have to go back and look which Wi-Fi they were on, but they were really the only successful networking protocol that had figured out, yeah, we didn't want to go through this time where you were buying Wi-Fi stuff that couldn't interconnect. So we knew that we needed to do interop for V6. And so it was interesting. It's officially, I'm going to wear my IPv6 ready technical chair hat for a minute here. I think what we officially tell people is it's a marketing program, right? It's a marketing logo that says that you do all of these, that you can interop with 2 hosts, 2 devices, you work together with a couple devices, and that you test all of these parts of these IETF standards we're going to get into later. So I started there, and that's when I started reading standards, right? And that's what got me really deep into networking. I had realized at that point that how different networking was. It was standards, which you need to write things down so that 2 people, you definitely run into the case of 2 people reading 2 different things differently and trying to work through that. Right. And so that's kind of where I started, was a lot of working with customers who were building early V6 implementations, reading the standard, and us helping them, or sometimes them helping us.
And then, and what's weird about that is later on is like after you've read about how people interpreted them and seeing this in the test environment, all of a sudden when you are now starting to write standards, right, which now both of us are involved in, you're like, holy crap, how clear do we have to be? You have to be like razor sharp.
You have to be really careful, and sometimes you're intentionally vague, because when you're trying to, I don't want to say boil the ocean, but when you're trying to cover more than one use case, you have to be kind of careful in that you don't paint yourself into a corner.
Right.
And on the other side of this, right? Sometimes you're trying to be so clear, but in other cases, you're like, no, I'm intentionally not being clear here, so that people have a little bit of latitude to do what makes sense for their implementation of their networking, right? There might be cases where losing packets okay, and there might be cases where that's going to be awful, and you don't want to do that. And so there's a line there that you quickly learn, right? And so Ready Logo was cool because it was a lot of collaboration. And so then I started attending the IETFs. IETF 70 was my first one. So that's Philadelphia. So I want to say it's 2008. 2008. Yeah. About that.
We should talk about how standards people measure time in city locations.
Dude, I measure everything, and you do 4s, right? At the broadband forum, right? You guys are 4 times a year. Yeah. So mine are, I started at 70, but then I have to backwards rotate how many times I've been to a city, or do it by, like you said, by numbers. I think I've only missed one, minus the COVID ones. I still attended those, right? The ones that weren't in person, but I've only missed one. That sounds right. I think I've only missed one in that time. So I went to a lot of IETFs. I started, the cool part talking about standards and journeys, the IETF is a very cool group in that it's really easy to get started.
Yeah.
It's very much like the analogy I give people when they ask me about the IETF is it's very much when you get to a roller skating rink and you go up the first time and people are like going around the track and you're like trying to figure out how to get on. I tell everybody, just get on a mailing list and sit there and watch people go around the circle a couple of times, and then you get a feel for speed, and then you can get on the. And then you get on.
That's really good, because I feel like people need to hear that, right? Especially, I can understand why people might often think that like going to a new organization, like sometimes might feel a little clicky, but in my experience that is kind of dissolved. And with the IETF, it's obviously different because it's orders of magnitude bigger to the stuff that I go to. But
yeah, I mean, right. The IETF is usually around 1,000 people, right? And the thing about that is even though you think it's that many people, clicky is the wrong word, but there are definitely people who are experts in very particular areas. Like, I'm not going to tell you how to do BGP or DNS today. You've come to the wrong place.
And it's got its own subculture thing, right? It's like there's famous people, they're
yes. And then there's the security that I call them the tinfoil hat people, not to be mean, but there's the security people there that are like, dude, they understand crypto algorithms way better than I, and they're doing their own thing. But I always tell everybody who asks me about getting involved with the IETF, I was like, the first thing you should do is just join things that you're interested in, work-wise or even personally. Like, hey, I'm really curious how this works. Just join the mailing list. And if you just hang out for 4 months, you'll see enough emails and be like, oh, you start reading the content and you start to catch on, and then you can jump on the the roller skate rink. And then you can get in the middle and go around the circle and figure out what you're going to do. So I did that for a long time. I did that probably from like 2000. I did it for longer than a couple of months. I was definitely watching for a while, doing a little bit. Sometimes you're just asking a question. Right. We wrote these test specs and you'd be like, hey, what does this actually mean? And you get really interesting answers from groups of people. So for a long time, I was definitely a passive observer. I don't want to say a wallflower, but I was definitely like I was getting more information than I was participating that way. I was learning from the group of people. And then I participated, the US government decided to do this initiative around purchasing IPv6 things.
Oh, yeah.
I was involved in that. They wrote a profile about the same time. So this all happened, V6 had been around for about 10 years. And people started to be like, okay, we need to do something with this after 10 years. And that's when the US government profile came out in 2008. And then that's when I started to get a little more involved, because at that point we were trying to decide what was going to help. And then the real push for my actual active involvement in the IETF happened around IPv6 in the home, in particular around the event called IPv6 World Launch. In 2011, they had a World Day that was all very much about 24 hours. We were so scared to turn on V6 on websites that we only did it for 24 hours the first time. I mean, that just to give everyone an idea, that's where we were at. And we turned them all on and it went pretty well. We found some issues. There's some well-documented stuff. If you're really into that, go look up IPv6 World Day, and then launch was a year later. But what came out of Day was a lot of the websites turned on V6 and they didn't get nearly enough traffic. And what happened, one of the things that came out of that was it wasn't deployed at homes. And that launched a year later, the initiative to get IPv6 pushed into homes. Because what was happening is these sites were turning it on, and then the service providers felt like they were getting blamed. Like, man, this isn't my fault. Like, there's a lot of my network does it, but the edge devices don't. Right. Is really the story. Right. That a lot of the service providers that were ready, very capable of doing V6 in their core, the home customers they're buying.
So when things were turned on, was it different for were there enterprises? I guess it'd be weird because it'd be dependent on the websites that they're connecting to, but
yeah. So the big websites that turned on are the ones you can think of: Google, Facebook. They all turned V6 on just to see what would happen. We ran into a couple. If you read the papers, there was a couple of black holes. Like we as a universe, the networking universe people. There was a couple of IPv6 issues where we had black holes for fragmentation, where packets weren't traveling back. We ran into a couple of firewall things where ICMP for V4 you can block, but if you block it in V6 cases, it ends poorly, right? And we wrote down some operational work that were like, we learned that's the perfect 24 hours. We learned all of these things. We were like, okay, we gotta fix some firewalls. But the other thing we learned is that
there was 24 hours of screaming, and that's where we learned.
Well, to give you an idea, we only gave ourselves a year, because then we did World Launch where everybody left it on afterwards in 2012. And that's how comfortable we were. We were like, okay, we can fix these. I'll put it this way. We did the test and it was, this is fixable. And so then we went to fix it. And that's why I really got involved, is we started writing IPv6, pushing it into the home, which is very different than what I would call the base V6 thing. It's taking IPv6, we haven't talked about this yet, but V6 for everyone who's novice to it is, going from IPv4 was 32 bits and IPv6 is 128 bits. So there's a lot more that goes into this, but in a nutshell, what it is we just expanded the number of addresses. But there's a couple catches. One is, for address space, the way I always tell people, all the V4 addresses fit in a golf ball. All the V6 addresses fit in the sun. Just to give you an idea, we weren't screwing around the second time. Right.
And isn't this like the way that we distribute the way that we distribute the addresses right now to homes, right? Most of them, you're effectively handing out a set of addresses that is enough addresses to address many Earths to a single household.
Yeah. Like your whole house can have the whole V4 internet size, right? So we weren't messing around the second go around, but there was a couple of catches that we ran into. So, when you deploy to the home, you lose NATs. And when we do that, that was where a lot of insecurities came up. Is there was this thing we had built for address translation to extend V4, where in your home you were using private addresses, but your server provider
which accidentally fulfills some functions of a firewall.
It does. It does. It also solves some problems like connection tracking. There's some features we got. The main goal was to extend V4, which it did. We also got some other benefits that I don't think we really fully realized. We got some accidental benefits from NATs that we didn't fully realize until way later, that we were like, oh, that was a really nice feature of NAT. Now, end to end also has some really nice features, which is what V6 returned.
Mm-hmm.
And that's where things started to get a little, with the home network in particular, is where we had to be a lot more careful. Because what happens at that point was we had to, check firewalls. It's no longer a NAT. We had to think a little bit harder about privacy. We had to think also about, service providers, how they're going to deploy this, timing. A lot of them, we wrote a whole standard about trying to figure out how to slow roll these, not making a flag down.
Right.
Like we had some issues where there was like, hey, we can turn on these parts, but if we don't turn it on everywhere, it's going to end. So we made some changes to DHCP. All of that was ongoing. So we did a couple of white papers, and I was pretty involved in that part of it from a standards perspective. And that's when I really started contributing back, is how I'll say it. There was a lot of like, hey, we're seeing this in the field. We went to go test some home gateways and we found these V6 issues. And then we're feeding them back into the standards process, which is where you start to write internet drafts and start to contribute back saying, hey, we're seeing this issue over and over again, whether it is an interop clarification or if it's something like, hey, we're seeing all these routing loops because these devices are getting confused on where its prefix is and they're shooting packets back.
Right.
We should do something about this.
Right.
Stuff like that.
So that's culturally, by the time you had gotten involved in doing that, and even to now, like how has the standards process, the ITF in particular, has it kind of evolved that way too? Or
so yes, here's Jim Bowen once explained it to me like this. He said, the ITU are the guys who show up in suits, right? These are the most put together. Everything. And
if you've ever been to the ITU, it feels like you should be wearing a suit there.
Yeah. And they're very like, they do their thing. They do it great. And then he's like, and then there's the 5G guys, they show up in business casual. And then the ITF guys show up in cowboy and Indian. Like it is everybody and anybody. And so it's a little bit different that way. I think one way it's changed a lot is it's not just a small group anymore. Not that it was ever a small group, but I think there's a lot of people who want to contribute to different parts of the internet. And I think that is really changed how, the process isn't that different. One thing that is different is they're putting out a lot more RFCs. There's just a lot more people want standardized now. And faster, right? This goes to the where we're in this world today, where agile environments and people want to iterate much faster. No longer should your standard be sitting there for, I don't think anybody's writing a standard now thinking it's going to be there for 20 years untouched.
Right.
Where I think when I started, that was
interesting.
They put a lot of planning into V6.
Right.
And I don't think you would do it that way.
Oh, I see what you're saying. Trying to cover all the holes before putting it out there.
Yes, they had several working groups just to try to they had IPNG. They had all these discussions about what features they wanted in V6. Like you got to remember, V6 started before DHCP for V4 was done. So they came up with the idea of Slack before DHCP in V4 existed.
Oh, wow.
So V6 had it baked in, and then V4 was like, oh, we should do DHCP. There's a reason that Slack, it was actually, if you look back at the standards, was before DHCP. And it wasn't until they later figured out, oh, we should have this protocol for giving host all kinds of configuration information, most famously including IP addresses.
Right.
V6 had already been like, V4 missed the boat on, they made me statically address all this stuff. We should just build in a mechanism that auto selects your address. That all became, but it took them so long to get that not out. But even when they wrote the standard, it wasn't implemented, as we discussed for a while. I don't think you'd do it that way today. I think it would be something much smaller. I also think it would be backwards compatible.
Right.
I mean, there was a reason that V6 and V4 do not cross streams. It's been helpful in some ways, but it also made deploying it very difficult. You had to have two routing tables. The two don't talk to each other. They're ships in the night.
Right.
They can interact with each other, but it's not the same as like there's no V4 device isn't going to process a V6 packet. And that had there's good parts, right? You don't have to worry about security patching it forever. Right. That's the massive upside is you're not freaked out about every V4 vulnerability until the end of time.
I like that DHCP. I didn't know that about the DHCP situation. And it kind of touches on the fact that there will be something that gets very quickly deployed because it is so damn useful that now everybody relies on, and now they're like, oh, well, can you do this using this, right? So,
Yeah, and
not to call out PPPoE, but
yeah. No, there's stuff like that. There's a lot of stuff like NetConf and Yang sat there for 10 years, basically unused until we came along and we're like, hey, this is really helpful in SDN type like situations. And then it kind of went everywhere. So sometimes we write stuff early that doesn't get used, and then somebody figures out the perfect use case, and then it's off and running.
So
I think the biggest difference in the IETF probably since I've started has been, and it's been 15 years now, has definitely been how quickly things come out.
Has that
they
changed
have a real,
since the pandemic?
They put out some pandemic stats. I'd have to go back and look at them. I think they kept or maintained the same amount. I think the big drop off they found was in new drafts,
right? Which
doesn't surprise me because often you and another guy talk in the hall, and then all of a sudden you've got a draft where you're co-authoring them and it's available.
Right.
I think it slowed a little bit on that. I don't think they had a slowdown on RFCs coming in, but it'll be interesting to see what happens this year because we're fully back in person,
right,
at the IETFs, and I expect they have a tracker for all.
No, it's totally true. But see, and that's I mean, we've experienced that in the office too, where it's like there really is a tangible difference between being in person and not. Now I can think of times, if we, I don't know if we mentioned it yet, but one of the standards groups that I'm deeply involved in is called the Broadband Forum. And you're totally right. It's like there have been times where there have been specifications that we started on a bar napkin, I'm not even joking, like literally on a bar napkin, we sketched it out, and that would never have happened.
No, it's listening to someone present, and then you see them the next day and you're like, hey, I wanted to talk with you a little bit more about this thing, which you might not do that on a computer. Having did the remote thing during COVID, right? The time change is the other brutal part.
Yeah.
Like
it's really hard to do an international thing.
Dude, the 2 a.m. IETF 6-man meeting, I got to be honest, I did not have my best stuff listening to people. Like it's tough. Yep. And so there's the upside to moving everybody. You're all in the same time zone.
Yeah.
And I know you might be jet lagged, but there's a little bit of you're all consciously there.
Right.
And that helps. But I definitely think there's no replacement for side conversations, or even like I said, just side thoughts.
But when it comes to the whole agile thing, did people get like more used to doing things more quickly because we're now doing it continuous, right? It's like we're doing the in-person meetings and then we're doing these side things and then.
Yeah, there's been a lot of push. There's a lot more stuff in GitHubs there's a lot more standards actually, like you can put MRs in or PRs in and you can see the document evolve. Back when, back in the day, it was sitting on someone's laptop.
Yeah.
Who was having an editor. I can't remember the last time I actually saw an IETF document have an editor where there was someone who was just collecting all of this info. You just don't do that anymore.
Oh yeah, you're right. Right. We've had a hard time sort of defining what that role is now. That we use.
Yeah, because now the editor is Git or whatever public location you have for the document. People can see it and be like, oh, no, you don't really mean that. Or you do mean that. You're almost group editing it, right? We've all been there with a Google Doc or Word doc or even with code. That's probably the biggest change is there's not some editor trying to merge all of that crap into one giant document. That process has probably gone away.
Right.
And yes, I definitely think things are revving faster. I think technologies like Quick, the IETF's latest transport protocol, I don't think that happens that way. Again,
Quick
is another one that, yeah. I mean, just getting it out the door, having another transport protocol. I mean, I think my networking professor from college would have had a heart attack if I had told him it's going to be something other than GCP and UDP in the world.
But I forget everything you know. But I know so much about it.
Right. For sure. But I also think that's what we're going to see going forward is that we're going to push things to be able to go out quickly and iterate on them as opposed to making perfect ivory towers networking wise. And I think that's probably a standardized.
So let's talk about that in terms of V6. So we often talk about how, the things don't get implemented until there's sort of a killer app, right? But when we're now trying to push stuff out there earlier so that it can sort of be tried out, even though it's not perfect, is that sort of accelerated the process? So we all thought that V6 would finally be adopted when we ran out of V4 addresses, and it obviously, that has not happened.
What you mean when when Aaron made its announcement in 2015, we didn't get there.
Yeah.
Yeah, yes. I mean, I think where we're at now is V6 is in a really interesting space, in particular in the home, in that we created transition mechanisms. And for a long time, that meant making V6 in the home work over a V4 network. And then somehow we flipped it on its head. And now, because we had service providers who couldn't get any more V4 addresses. So the killer app for V6 ended up being we ran out of V4 addresses. Ended up being the killer app.
Right.
And I say this in two ways. One is, for a long time, we didn't have enough devices on the internet that this really mattered.
Right.
We do now. And that's the major changes. Now, before it was like, hey, we're running out of address. And it's like, we can come up with ways to engineer around it. Now that I have, 40 devices, 40 things in my house are connecting to my home gateway alone.
Right.
Right. Is now you're reaching, I can't even think of what like a smart building. My house isn't that smart. And if you had if you build a brand new building today and everything was connecting to talk to you to give you reasonable metrics about just, hey, I'm working, whatever the thing is.
Right. And that, I mean, it's we talk about Matter and how it is cool and terrifying that they said, no, we're just running over V6.
Right. Because, what happened, two things happened, right? We ran out of, service providers could no longer get V6. And so two things happened. One, T-Mobile on the wireless side, on the cell side, they decided to only give their cell phones V6 connections.
Right.
And when they did that, they were like, V4 gets carried over a slightly slower over my V6 connection. So they switched the way transition mechanisms worked. It was kind of genius, right? They said, now we're transitioning with it's still one hall. It's not V4 on the upside, on the upstream, it's V6. And so now transition mechanisms are making V4 work in the home, which is totally backwards.
Right.
If you had told 25-year-old Tim Winters this, he would have looked at you like you had lost your mind.
Right.
Because what happened is then you can then you're not taking the pressure off the core network. The network operators who are network experts know how to track an IP address and know where you are. And then in your home, you can have both. Do whatever you need to do.
Right.
But on the edge, we're going to flip it over and send it out. And that's where things got a little bit different. And then that's where then people wanted to take advantage of just keeping V6 everywhere. And that's where Matter, like you said, comes in, is now you have all these home technologies, all these home devices that can take advantage of. So we're really seeing growth in IPv6 in two spaces. One of them is, I would call it the 5G splicing and slicing. What happens now is we have all these V6 addresses. You can get really creative. Like, all of my voice traffic gets labeled with these V6 addresses, and all of my video traffic gets labeled with this. My voice and video have two totally different prefixes, so a router can instantly look at those those top 64 bits and instantly be like, I know where this goes, and not having to look at the entire payload.
Right.
And you start playing games with splicing and slicing and microservices, and V6 makes so much more sense because you have so much more area to play with.
Right.
And this is where the overlays and all this virtualization and cloud stuff, V6 can propagate, works very nicely in all of those environments. And that's where, and then for the home people, it's just an amount of devices. The amount of things in your home that are connecting or that you want to connect goes up, as I say, every day.
Are there any features about it other than the number of addresses that are making it conducive to that world?
I think that the number of addresses, also how quickly and easily it gets online. It can self-address itself. It can create its own network. We have this whole concept of global addresses that make it so that you can route amongst mobile things. We're still doing some work. Service discovery is tough. Service discovery has always been a problem, in particular, trying to make, we've all been here. You're connected to one network in your house and you can't see your printer and everybody loses their mind. Like, that's the classic
printers
story.
Specifically.
Yeah. So we're still doing that. And then the other thing is, I talked about being agile, but we're always conscious. You want to be careful of security. What you don't want to do is put something out so early that you have such a blatant hole in it that you're
right.
And there's a fine line that we're all walking when it comes to that problem.
That's what I was going to sort of mention next is like we have the standardization world and the world of the people who are like, let's just build this. Let's build it. Right. You have people who are writing open source code right away for a new standard, but then you have the business side. Right. And the one thing that, you have people who have invested so much, right, and it's not just, it's not just in the technology itself, it's in the personnel, right? It's in the knowledge that's out there, right? And people don't want to, they look at total cost of ownership and they're like, well, can we just squeeze a little bit more, right? And so when it comes to doing the agile deployment standards and pushing stuff out sooner rather than later, we both run into situations where an earlier version of something is the thing that gets sticky, and you want to make sure that doesn't happen.
Yeah, no, right. What happens is the massive security flaw that CVE comes out, right? And you just hold your breath. Like every time I see V6 CVE, I still to this day, Jason, I'm like, do I want to open this? That link comes in and I'm like, what's going to be on there? I'm sure the same thing's true for you. When someone sends you a TR669 exploit, I'm sure you do the same thing, right?
Yeah.
At this moment where you're just like,
yeah,
what's this gonna say?
Right.
Like, is it gonna be something that we knew about, or did we just totally screw this up?
Yeah.
And so the thing I tell everybody is you want to be fail fast. And I think the networking world is way better shape for deploying stuff. The IoT space are spending a lot of time matters too on the onboarding and updating of firmware and all of that.
Oh, right.
That's the thing. Right. You better have that, or you're in real trouble if things can't update.
Right. And the more things that we containerize and turn into software defined things, right, makes it so that risk is reduced.
Well, software defined thing also so that you can update components, right? One of the big changes I've been seeing lately definitely in home gateways is more compartmentalization so that you can just update one component.
Right.
Because then you don't have to worry about waiting for the whole shebang to be done. You can be like, okay, just update your firewall or update your service discovery mechanism or your Wi-Fi, update your Wi-Fi driver, or your Wi-Fi telemetry, whatever it is. You can just update that component without worrying that you've got this trickle out effect. You pen them in ways, whether it's containers or whatever you do, to try to aid that so you can put stuff out earlier, faster, more effective without worrying about damaging other things. Kind of penning yourself in, right? I mean, that's the upside to containerization and these microservice architectures is that they definitely protect you a little bit on not having to understand every component, because it's really hard. If you've ever, if you ever studied a standard that's more than a couple layers, it's really hard to figure out how you're going to
and to figure out what will possibly happen when you change things, right? Because in addition to the cost associated with these things, I'm sure that there's a lot of not just operators, but anybody, any large organization that's going to deploy a network like this, like there are things that it's like, on paper it says it's not going to break, but it's probably going to break.
Yeah, right. I mean, this is all, we spend a lot of time doing this. I'm all for proof of concepts. I do love, the IETF was definitely pushing and always has running code where like, great, you put this in theory, but it'd be really good to actually see this in practice, right? And that's kind of one of the things they try to do. I think there's real benefits in that. And today it's almost gone the other way. Is sometimes there's running code long before there's a standard where more people are trying to read it and understand.
It's true. And we've gone in the reverse direction too, right? So it's like we've had people sort of come to us with open source code and we'll be like, well, why don't we standardize this? Right? Yeah.
No. Like, there's a whole group of people that did this and it's like, that's great. And people are grabbing it. But then there's, it worked for that problem, but that doesn't necessarily scale. Scaling is one of the big ones that we run into where a open source implementation works great in a very small environment. And if you blow it up, all of a sudden, all of these problems occur because it wasn't designed for that. It's very much like the Apollo, when you watch Apollo 13 and they're like, the lunar module wasn't built for this. Like there's definitely things that get used in ways that on the networking side that they weren't built for. And you have to just kind of rethink how much memory or how much space or how much thrashing. We did a lot of stuff. V6 works very heavily on multicast, and we're really having a struggle in some wireless technology spaces because wireless hates multicast.
Explain a little bit, just really quick, so that people aren't like, "It handles it just fine, Jason." No. I can't believe Tim said that on it.
No, So the deal here, right, is we spent a lot of time when V4 was being made. There was broadcast packets; they've always existed. The Wi-Fi chips, Wi-Fi APs, spent a lot of time figuring out optimize that, unicast them when they could, figure all this out. V6, there's no broadcast domain. It's a multicast domain everywhere. And that has some really great benefits. But when you get to site local things, it's really painful, like router advertisements being sent to everybody for a long time.
Oh, yeah.
Yeah, no, that didn't go well. And there was a really interesting study by some of the early phone people that were creating handheld phones, Android, Apple, all of them, that router advertisements were being sent by these home APs every 4 seconds. And well, if an Android listened to every 4 seconds of those, your battery caught on fire after about an hour and a half.
Oh, yeah.
Like it would just kill your battery because they had to wake up. Having to wake up the battery radio every time was ridiculous. So they had to come up with optimizations to deal with that. And that's kind of, this is what I'm talking about when you go to scale is you're like, great, router advertisements work great on an Ethernet network. There's no problem there. But the minute you stuck them on a wireless network and you were killing batteries everywhere, it's like, we need to come up with some mechanisms to deal with this. And so you write these standards and the idea, you think they're going to work in all these cases, and then you get into, and then you have to be careful because then what you don't want is somebody on an Ethernet link or on a high-powered link reading the Wi-Fi standard and being like, great, I don't have to pay attention to these things in these cases. And it's like, no. If you're in a data center and your guy wants to change which way you're going for a router, you better do that. Like you better be on that or somebody's going to be really unhappy.
Right.
And so it's like you said, it's trying to put the words in where you're like, I want to be vague here, but I want you to understand the context of this. Like you do what you think is best. We're going to put an IETF should, which make the right choice here. You should really do this unless you have a good reason not to. And people sometimes don't read that the right way. And it really should be that. Yeah, I have a good reason not to wake up every 4 seconds when I get a router advertisement. It's the same as the last one you sent 4 seconds ago.
Right.
Like these packets are no different. Me burning through a battery, that's just ridiculous.
Right.
We shouldn't do this. And we should come up with better ways. And then we figured out how to unicast RAs and we solved it. But that's where some of these things that existed for 20 years. And then we started to hear about it. And we're like, okay, we got to change this. This has got to change.
And where the initial use case changed, or it's like the reason why it's like, yes, we know this is vague, but we had to do it this way, and we can't define it any further. We can tell you what you probably should do, but if we restrict this in any way, then it's going to exclude an entire,
Yeah. And, with V6 in the home, we were doing the same thing. We created this giant thing called HomeNet, and we couldn't get it to work. We couldn't get anybody to pick it up because that was too complex. And now we're kind of going back to the drawing board, trying to figure out, okay, we've got V6 from the service provider to the edge guy, but how do we get that to the next step in the home?
Right.
And that's really important for these Matter guys, for these Thread guys, for, great, I can get V6 just to the edge of your house, but how do I get it to the next router or hub? Right? Because IoT space, if I'm going from Wi-Fi to some other Bluetooth, whatever technology, I need to figure out how I'm going to make that work in a non-bridged environment because it just doesn't make sense.
Right.
So, and that's kind of the evolution of where we're at is it's like, okay, let's take the next small step and let's figure out what we can do in this space without doing.
Is the push there, or is it going to take another push?
I think there's a push there right now. So originally when we deployed V6 to the home, right, we got to the edge and then everyone was like, okay, we want to make it work all in the home. We want to solve all of these problems. And the IETF started a very nice working group that spent a lot of time called HomeNet.
Right.
And they built this really cool, I loved it, a really cool mesh system that could figure out which direction it was going and address your whole home. And no one implemented it, basically. It got implemented in open source, but none of the lovely customers that we have implemented it for very good reasons, right? It's very complex. And it was going to have a lot of moving parts. And I think that was too far. There was a bridge that we had made that was too far. There's a new IETF group that's focused on, it's called SNAC, and I'm going to get this wrong, Stub Networking Auto Configuration. And that's really for trying to solve the interim problem.
Okay.
It's like, hey, they took HomeNet and they scoped it. And that's what you sometimes have to do. You have to tell yourself, like, we shot for the moon, we went too far, and now we need to come up with the middle ground, something that'll get us stepping in the right direction. And I think that's also a standardized change. Right. I think people are way more accepting of taking the next small step. Hopefully, like I said, you have to be careful not to paint yourself into a corner standard-wise when you're writing these things. But you also understand that, hey, I don't, people seem to be much more comfortable writing words like out of scope.
Right.
Like someone someone else can go work on this problem. We might work on that problem next.
And it's perfectly okay
right
to
now,
later write an implementation guide where you're like,
yes,
in this case, this is what you should do. Right. Using the tools at your disposal. Right.
Yeah. Or even additionally, like, hey, putting something out there and literally being like, we're going to come back to you with when we learn after this gets deployed for a little bit. We're, leaving, I don't want to say TBDs in the standard, but leaving things that you were like, hey, they got cut, very much like a movie, like not the director's cut, but the other cut, where like there were ideas you had, but you
what
were
is
like,
this reserved field?
Like, what are we going to use that for? Like, we left TLV options. There's only one TLV option right now, Tim. And it's like, yeah, don't worry. People will come up with more later. Right. And so that's kind of where you start. And then you give people just enough room to move on, for sure.
So before we run out of time, I have a couple questions. So the first one is, do you think IoT is basically it? Like that is really, really the thing that's like going to explode this for the rest of the thing, until we start going to space and having to address every molecule of hydrogen and whatever what was it they said? Oh no, grain of sand. Is that what it was?
Grain of sand. Yeah. Every grain on sand has a V6 can have a V6 address on Earth. I never actually did the math. Someone told me that. I think that's true. I hope it's true. I hope no one fact checks that. The answer to the question is yes. I think it's just connected devices, right? And we talk about IoT that way, but it's also, think of like virtual environments. Think of like data centers. Mm-hmm. Like you have so many things in a little rack now. If you're in a cloud provider, if you're Amazon, if you're AWS, if you're Google, if you're Oracle, whoever it is, you have a gazillion things that you're addressing inside of your network. And so I think really what the answer is yes, as more things are going to be online and communicating, right? More things are going to want to communicate with other things. And then when you get into microservices, things that were using one IP address now have 7 or 20 because they've broken up what was doing it once. Now it's like, no, man, my only job is to report on the Wi-Fi information. My only job is to report on the GUI or make the LED light blink. Like as you break up these microservices, in particular inside of a network, all of a sudden what was one address because there was one server figuring that all out, now it's you've broken it out. And V6 is your only hope. Right. And if you're trying to do that in a V4,
you have some sort of automation that is now eventually run by AI that's like, I need to create 10 things, 100 things to do this job really quickly, and then they're going to go away, right?
V4, you're capping yourself almost instantaneously. You're capping yourself. Where V6, you get so much more room to be able to do that stuff if you need them to interconnect and talk. And then IP everywhere is, really the answer to this.
Right?
Is IP makes it. If you do IP everywhere, whether it's between these microservices or it gives you options to overlay them, put them wherever you want. Even if it is internally, you start internally and then you can break it out.
Right.
And that's where all the magic happens. Right. And so I guess my answer is yes. I don't think IoT alone, no, but I think there's just more things out there that want to talk to one another.
That's a good feeling.
I don't know. Some days I think so. Some days I don't. It depends.
So what it was, not to put this on the spot, what would you say quickly is the weirdest standardization story that you have? I know I have a couple in terms of like the kinds of people that showed up. when I ran into a literal mom and pop telco at a telco thing where it was actually a telco run by a mom and pop.
Mom and pop? Wow.
It was like this guy and his wife, and they ran a telco.
Man, I'm trying to think standards wise. There occasionally I'll see the V8 draft come in. And I have a heart attack. Someone like that always gives me a moment of just like, that kind of stuff always gives me a moment of like, you didn't watch how fast people were going around the roller rink. You just went straight into the middle of that.
Or the people who are like, here's the way we can still reuse this segment of IPv4.
Well, right. I mean, there's recently a group of people that was kind of bizarre. The group of people trying to extend V4 addresses. They were trying to figure out how to use them. I mean, I get it. I think there's some value there. There's some unused addresses, but ultimately, yeah. I mean, standards body wise, I don't think I've had a lot of weird ones. I think I've spent a lot of time, it's gotten better on the must and should sides. The really tough part is when you're fighting over something someone wrote 20 years ago.
Yeah.
That's probably been where we're fighting over something in a standard that nobody who wrote it's involved anymore, and they were not as explicit as Harvard. Intentionally.
It's like trying to judge the framers of the Constitution.
Yeah.
Right?
Yes. You actually get into those kind of things where you're like, I think this is what they like. This has been this way, and then you start wondering, like, why has it been this way for that long? I think is another thing that we've been experiencing a little bit.
Right.
And then there's fear when you go to update them. There's a little bit of fear that you don't want to change too much.
Right. Yeah. Cool. All right. I mean, that's it's like I was saying, it's not hard to fill an hour of time with talking about this stuff. It's not at all.
Great. Jason, I think this is a great idea you're doing. I'm super excited to hear more of these. I'm definitely super excited to hear ones that don't involve me. So.
I understand. It's like, is that what my voice sounds like?
Yeah. But I'm looking forward to hearing more of these. I'm super excited about this.
Cool. Me too. Me too. All right. So yeah, that's what we'll do for today. I have a short list of the people that I'm going to have on future podcasts, and some of them are prepped and ready. So I'm not going to mention them yet, but when we get sort of the site up and I'll talk about those things. Obviously, follow Tim and myself and QA Cafe on LinkedIn. You'll see updates there on future episodes, and always more things where we're talking about these exact same topics all the time, because we liked doing it for some reason.
Yeah, we got in a long time ago, Jason.
You'll never get out.
No, it's true.
All right, cool. All right, well, thanks everybody for listening, and I hope you'll tune in next time. And until then, try to find the fun in the nerdy stuff. We will. Thanks, Tim.
Thanks, Jason.